Hello again, and we are back online. Thank you, Alex, for being with us at joining JNation 2021. I hope you are well.
I am. Thank you. It's really good to be here. It's really good to be here.
I want you to know that attendees can ask questions on two platforms. One is directly on YouTube, and the other one is on the Track channel on Slack. You don't need to be aware of it. I will relay the questions back to you so you can keep up with your presentation without interruption. So I think this is all. People know already how it works. I will pass it back to you if you don't mind. If you can introduce yourself and start your session, it will be perfect.
Perfect.
Thanks, Alex.
Perfect. Thank you. So, introducing myself, that's a hard one. I do a lot of things in this world. And one of them is I volunteer to Mozilla. I'm a Mozilla mentor, reps mentor, and a Mozilla tech speaker. And that means that I like helping people kind of interact with the web. Now, because I like the idea of a paycheck and, I have bills to pay, I also work at a Portuguese company actually called Fidel, where I'm a developer relations manager. If you don't know what that means, don't worry. Most people don't. What I do is I help people interact with the Fidel API. I help developers interact with the Fidel API as easily as possible. The Fidel API actually does a few things. One of them is serve real-time transaction data. But I'm not here to talk about the API. I'm not here to talk about Fidel. I'm here to talk about performance debugging on the web. And that's because before I was a developer advocate or a developer relations manager, I spent an insane amount of time being a web person. I actually have code that's running in the Firefox DevTools, and I was for a really long time before Firefox DevTools was a thing. I was the DevTools owner, so I kind of picked up a few tips and tricks on how to use them to solve a problem. Now, today's presentation, whatever, isn't actually a presentation. It's a hands-on performance debugging session. So everything happens live. That means I'm going to need a little bit of help from everybody when we start. I'm doing this on a website of your choice. So you get to pick the website I'm going to inspect and debug live here. Use either Slack or the YouTube chat or whatever to send me a website. And I'm going to use that website throughout my entire presentation. And we're going to see what you can do to get a website to load as fast as possible, to improve the performance of a website as much as we can in 50 minutes. I'm going to show you pitfalls, how things should work, what things are broken, and a bunch of other stuff you can use to debug any website. And right, if it's your company's website, I promise I'll be gentle. I'll be really, really gentle. If it's something generic like Google and Facebook, it's been done to bits. I fairly think those are websites where we won't learn a lot of things. So when you pick a website, pick something that it's going to be useful for you. Pick something that's relevant for your work, and something like that. In the meantime, while I wait for questions for websites, I'm going to go ahead and enable the tools I'm going to use today. As you can see, my debugger, my browser of choice today is Firefox. These things I'm going to show you work in any browser, any major browser, kind of the same, similar. When there's a difference, I'll tell you about it. The reason I'm choosing Firefox over anything else is I worked on it. It's kind of I have an emotional connection to Firefox, and I keep using it, and it does help. The JNation website. Okay, Dennis, I've done this on conference websites before with, well, let's just say some conferences never called me back to speak again. Hopefully JNation is going to call me back after they're back in Portugal on the beach. We'll see. Okay, I'm going to use the JNation website. So it looks a little bit different, and that's because I disable most things that I'm not working on. The only things you can disable are the inspector, the console, and the debugger. So for now, the things I'm going to work with are going to be the network editor, the performance editor, and the memory inspector. And they show up here, right? So let's go and choose the JNation website and see what happens here. So
yeah, that will be interesting to see.
It will be very interesting.
I guess a lot of people are scary right now.
Right. So this is a lot of requests, right? So I look at these now because I have the JNation website actually open in another tab. I'm gonna go ahead and do a hard refresh so we have clean data. I already have disabled cache, so I shouldn't get cached resources. Just in case, I'm gonna do this again, and we'll see how long it takes. So DOM content loaded was 3.75 seconds. And load was 5 seconds. As you can see, when I did a hard refresh, the numbers were 2 seconds more than before. And that's because even when you have cache disabled and everything else, there's some things which aren't technically cached by the browser that cached by your system. So hard refresh kind of flushes everything and takes everything from the start. Now, the difference between DOM content loaded and load, there's a difference here. And usually you're going to see a difference because JavaScript is going to, DOM content loaded is going to load your DOM, and then it's going to start running JavaScript because it finds JavaScript in the DOM. And that JavaScript is going to fire off another load event, and that's going to do more things until it's fully loaded. So you can see in here how much everything kind of took. And we're looking for the first thing we're looking for, because there's 3 parts to running a website performantly. One of it is getting all the assets into your system, right? And that's what we're going to inspect with a network tab. The second one is how fast is your JavaScript. And when you talk about performance optimizations and performance debugging, everybody goes straight to that JavaScript bit, right? We all know JavaScript is slow. We use big frameworks, whatever. No, because most of your time spent until JavaScript runs, that's going to be the biggest thing. That's going to be the biggest performance optimization you're going to be able to do. That's the 80% for the 20% of work, right? And that's because you're depending on the size of your assets, you're depending on the network until you depend on the client to run your JavaScript. And the third bit is, so after you've downloaded the assets, you start running them. That's when JavaScript performance starts kicking in. After you've run the website for about half an hour, so for example, the JNation website, right? You probably won't have this open for half an hour, like myself. Think about, I don't know, Gmail, for example, right? Or Twitter or Facebook, those websites that are apps, basically, that you have them always running. After about half an hour, that's when that JavaScript kind of fills up all the memory you have available, and memory optimization becomes a thing. You're only going to need the memory optimization bit for maybe 2% of the websites. I'm writing the markup, like the markup chapter of the Web Almanac this year, and we have a bunch of tests running on like 10 million websites. If you want to find out something about that, I have a poll running on Twitter. Go on my Twitter account. But only like 2% of the websites need that memory optimization. And we're going to talk about that towards the end. First of all, we're going to focus on that network bit, right? On getting your assets as fast as possible to the client machine, right? And that's done with 2 different things. There's the transfer size and the actual size. The transfer size is the one that matters because most websites use compression these days. You get the assets compressed and they decompress on the client machine. Decompression happens in an instant. It's really not important. But the transfer size is the size that goes through the network, the size that goes literally on the internet to get to the other side. And that's what you're trying to make as small as possible. And we're looking here at differences between transfer size and size on disk. The things that are going to be the same are basically images. You can't recompress images, but you can compress and recompress like scripts and CSS and HTML and everything like that. So we're going to look for the differences in there. And that means it's not compressed, right? If there's no compression enabled, the transfer and the size are going to be exactly the same. And we're going to look at the things that are different, right? The things where there's a big discrepancy in here. So for example, like this, looking at the scripts, it looks like most scripts are compressed. Which is really a good thing. You want the scripts to be compressed, right? The size that's transferred compared to the size on disk is quite big, like 5 times the difference, which is kind of like the average you're trying to go for. Like 5x is what you're aiming for. That's 20% of the actual size. That's a good compression rate. Of course, when you have small files, you won't find the same compression level. Now we're going to look at, so compression is enabled. That's really good. I'm going to guess, you've got a lot of scripts in different places. So the ones on JNation, right? Those are compressed because JNation uses compression. The ones that are external WP.com. I think that's a WordPress thing. Hopefully, I don't know. Whatever's on a third party domain, on a third party server that's not part of JNation isn't compressed because you don't control it. So for example, Sessionize or WP.com. Here's the trick. You can host those yourself on JNation. You can download them from the third party and host them yourself. Then compression kicks in. So one of the first things I do is I'd make sure I have no external third party script hosted anywhere. Like you can download any script you want and host it yourself. And that's one of the big things I do. Now I'm gonna look at one of the requests. Let's make it fair. Let's make it a JNation request. That's a lot of requests. 400. You've got lazy. You've got some sort of long polling, and you keep making requests, and you keep making requests, and you keep making requests. Okay, this is gonna be interesting. Let's look at one of the requests that was on JNation, one of the bigger ones, and see what happens. And then we'll go on one of them that's not JNation. Okay, let's pick this one and see what happens. So if I look at the request, there's this little tab in here called timings, and timings shows me the anatomy of an HTTP request and how long each of those steps took. So the anatomy of an HTTP request is you want to get JNation.pt. First, you go to DNS and you get an IP address for JNation, right? And that's the DNS resolution. That was instant. And that's because DNS resolution happens locally. JNation is probably hosted in Europe. I'm in Europe. I went to the Frankfurt DNS. The Frankfurt DNS had the answer for me. Congratulations. It's all across the globe replicated. I have to go to some weird part of the world to get my DNS. That's the good one. Connection and TLS setup, that's because it's an HTTPS request. So TLS setup only happens on HTTPS requests. That took absolutely nothing. The sending part, because it's a GET request, is also nothing. That means I have a really good internet connection because I'm not throttling. Now, I sent my request, and then I waited 70 milliseconds for the server to do something. And this is bad. This is the first thing you could improve. The server doesn't have enough resources. Too many people going to the website, trying to load the website. The website can't serve everybody in a fast time. I would increase the resources on the server, right?
At least we can use that as an excuse, right?
Yes. Thousands and thousands of people on the website right now. That's a good excuse. But I would increase the resources on the server, right? The more the server has resources, it doesn't make me wait. It doesn't make me wait for my requests. So I waited because the server didn't have enough resources, and that's one of the optimizations I do. The second one is the receiving part. And this is a fair amount. Like I got, how much data did I get? 34 kilobytes. I didn't get that much data to be 67 milliseconds. Maybe I hit, in between me and the server, I had some sort of a roadblock. I went through a slow network. I tried looking at CDN or Edge. I know everybody kind of went a bit crazy when Fastly went down the other week and the internet stopped working because of the CDN. I'd look at that. I look at the CDN structure that's closer that's globally replicated, closer to myself. So the receiving part would be even lower, right? Here's the trick. When I look at all the requests, most of the things that happened weren't that bad. The problem was this big line here that says blocked. And there's a reason because why requests are blocked. Like blocked means the browser has a finite number of active connections it can have at a single time. Depending on your browser, your version, your whatever, it's either 6 or 8, or there's a setting that you can go and change on your browser to have more active connections, right? Most of your users are going to have that default number. And that means I was in a queue waiting for an active connection before I could actually go out and do all the things. So I was blocked for 550 out of 800. So 70% of the time, this request was idle, right? I could shave an incredible amount of time out of the whole loading if this request wasn't blocked. And how do I do that? Now, if you're using HTTP1, you can do connections to an URL. So, for example, these two things, right? Two different URLs. That means each of them takes a connection slot. If you're using HTTP2, you're doing connections to a domain name. So these two requests, because they come from the same domain, from 2021 JNation.pt, they go through the same. You can have as many domains as, like, you can only have 8 domains, but as many connections to that domain as possible. Now this happens because you're breaking both limits here. If I look at the headers, it's an HTTP1 request, it's not an HTTP2 request. And this is like a major thing in 2021. I think most of your problems of that 5 seconds will switch over instantly if you switch from HTTP1 to HTTP2. Right, that's one of the biggest things. And if you look at most websites today, HTTP 1.1 is not really a thing. Really not really a thing. Like most web servers have defaulted to HTTP 2. The fact that they have HTTP 1, I think that's the biggest flag for me right now. Right, which is okay. It's fine. Don't worry. It's one of the things that's easily fixable, and you have a massive boost and a massive improvement if you switch from HTTP 1 to HTTP 2. But because it's on HTTP 1, that means every single link stays in a queue, right? And there's only 8 going at a time. Now, I've got 800 requests so far, but that's because there's a lazy loading script. If I go and look until the lazy loading kicks in, it's probably 100 to 200 requests. How do you fix that? Like, when there's only 8 active at a time, and like there's places in a queue, right? We can go only 8 at a time, and you've got HTTP 1. If you can change it from HTTP 1 to HTTP 2, right? There's another trick you can do. You can combine everything into one script. So,
Alex, I was asking you, I was going to ask you about that exactly, because the old recommendation for HTTP 1 was to merge all the files you need into a single file, because it will be a lot faster. But now with HTTP2, that's not a recommendation anymore, right? So it's better to split the files.
That's the trick. You're splitting the files, but you're using HTTP1. So you're doing the worst of both worlds, right? So if you're using HTTP2, if you're doing HTTP2, you can have as many files as long as they're served from the same domain. Even subdomains count. So if you have 2021.JNation.pt and you have assets.JNation.pt, those are 2 different domains because the subdomain counts, right? So getting everything into the same subdomain on HTTP2 means you can have the files split. That's why Webpack does the split files right now, because it assumes you're going to do HTTP2 with it, and it doesn't compress everything into one. But if you're using HTTP1, like you are now, right, compressing everything into a single file, like all the JavaScript in one file, all the CSS into one file, means you've only got 2 connections, right? That's it. And because that request is compressed, you don't have to make sure every single thing is compressed. You have to compress one thing and one thing only. You have to request one thing and one thing only, right? So all that back and forth, like if I look at the timings, right, the waiting doesn't happen for every single request I make. So instead of having 200 waiting times, I have 1 waiting time for HTTP1, right? For HTTP2, you still have the same problem. I'm sending like 200 requests because HTTP2 allows me to send 200 requests, but I still have 200 waiting times. So if you can't add resources to your server, you can compress everything into one file, right? I can't give more resources to my Amazon instance, for example, right? Amazon is expensive and I don't want to pay more for Amazon. I can compress everything into one single thing, and I can wait once instead of waiting 200 times. So that's, even though HTTP2 allows you to have everything split, there are benefits to, even though it's HTTP2, compressing everything into one file, right? So let's assume everything in here was magic and it kind of worked together. We managed to make the files as easy to get, as small as possible, and we got them into the client, right? Which is perfect. That's what we were trying to do. And out of those, so if I look at the timing here, right, down counted loaded 3.75 seconds, I think I can achieve an 80% improvement just by compressing files into one place, right? And that means it drops under the threshold. So the threshold is between 1 and 2 seconds. If it's smaller than that, people are going to assume your website didn't load are going to do a shift refresh, a hard refresh, because we got cached resources, especially since your audience is developers, right? If a website loads too fast, I'm going to think, oh, the service workers, definitely the service worker got me stale things. Let me shift refresh. If it takes longer than 2 seconds, your users are going to think your website is really slow and they're going to move on. Like, it's a shitty website, we're going to move on. So that's kind of the sweet spot you're going to try to stay in, right? And it's okay if DOM content loaded is the one that gets there, because DOM content loaded means things happen on the screen already. So it's time to interactive that's measured by DOM content loaded. The full load of it can be later on. For example, there's a lot of images on the website. There's a lot of other things that can load later on, right? But the website is still usable. So the load time can be way longer than those 2 seconds that you need, right? Okay, so imagining we did all this and it's compressed and it's fast. I've been on the website for a while now. What happens to websites after the JavaScript on them runs? So for example, this one has a lot of JavaScript, a lot of scripts, right? A lot of things that run. I'm going to try to figure out how the performance of all that JavaScript happens. Now, this is the performance tab. And the way the performance tab works is it's not always active, because a system that's monitored gets affected by the monitoring software. So technically, if the performance tools were always on, it would slow down your website. So we're going to just turn them on, record the performance of the website, do a refresh, stop recording. Now, the way recordings work is I'm going to record this website twice today. I've recorded it twice already, whatever. It's going to be slightly different results, right? And that's because the internet and its mysterious ways, your system, I know, a notification popped up and your systems use slightly different resources. The way to kind of make sure you're catching the relevant bits and discarding the irrelevant one is to do more than one measurement, more than one recording, and kind of compare them and figure out these things happen in all the recordings, and that's what I'm going to work on. These things don't happen in all the recordings, so there are probably flukes, and I'm not going to spend time investigating it. How many recordings? Depending on where you look online, there's going to be different numbers. The whole idea is to be statistically relevant. So 3 to 7 is kind of a safe number of recordings. Anything past that, no, too much work. Anything below that, it's not going to be statistically relevant. Because I'm lazy and I don't have the time, I'm going to just record once, and we're going to look at the recording and we're going to talk about it. But if you do this for a website, you should try to do it at least 3 times or 3 recordings. Now, there's another trick. If I record it here and you record it there right now, our recordings are going to be slightly different again. Different machines, different parts of the world, everything like that. But when you work in a team, and more than one person works on a website, right? You're going to want to have and kind of work with the same data. So recordings can be exported and imported back. So I could technically be working with your recording, or you could be working with my recording. Use one of the machines as the benchmark machine, and everybody can work with that recording instead of having to record themselves. So I'm going to start recording the performance. That gives me a dirty website, because I've been on the same website for about 20 minutes now. A good 20 minutes. I'm going to scroll for a bit, and you'll see as things happen on screen, my frames per second drop, which is still good. And now I'm going to do a shift refresh. My frame per second are supposed to drop to 0 and start again. Perfect. And I got to the end of my capacity. Like, there's only a certain amount of buffer space I have to record performance. So let's see what's happening in here with a full buffer. So this recording I did, I could save the recording, and that's gonna allow me to send it to anyone, and they can import the recording from there as well, and we can all work on it. So I'm gonna. This is interesting. It hasn't beach balled on performance. My laptop hasn't beach balled on performance recordings for a while. And that means it's a quite heavy website, or the fact that I'm running YouTube in parallel for my website. And that's going to affect the performance of it a little bit. Okay, so let's try this again. I can look at individual bits of it. So instead of having to look at the entire thing, let's look at the things that were problematic. It's color coded for me. So I'm going to look at this little bit in here. And this is, I see exactly what happened. It's color-coded. So yellow means it was JavaScript. Yellow and black means it was DOM within JavaScript. Purple means it was CSS, and red means it was garbage collection. So if I look at it, there's a lot of request animation frame, and that means there's a lot of animation happening on the website, right? And the fact that I have seven different request animations, or the fact that I have a lot of DOM events, that's because, so this one, for example, this is a scroll event, right? Some element of the website has a scroll event listener. And that means it's like 4 layers deep, because it captured and then it bubbled 4 times up, right? It captured and it bubbled 4 times up, right? And that means everything that's way down deep and it's capturing events is going to bubble all the way up. And that basically one event I'm listening for is going to have 5 times the amount of events in it. Actually, the bigger your HTML tree is, the bigger your DOM tree is, the more events is going to bubble up the chain. You have to think about where exactly do you need the event to happen, instead of putting on the lowest level event you've got, right? For example, it's a button. Do I really need to know if it's on the button, the text, or actually the container element, right? And think about that when you create your event listeners. It might be convenient to put, for example, scroll on an image, maybe. Maybe I don't need the scroll to be on an image. It could be 3 layers up, and that halves the amount of JavaScript that has to run because of that bubbling event. That's one of the good ones. The other one is the fact that you have animations. There's request animation frame, a lot of them, and I can actually see the stack from where it came. Ooh, there's a lot of events. So the stack is really, really deep, and it has to do with jQuery. The fact that it's minified jQuery means I won't even open it. But that's a lot of request animation frames within it. I'd look at, so if I wanted to improve the performance here, I'd look at maybe getting rid of jQuery and using the actual request animation frame to do my animations. I know that's, bear with me, I know that's a bit of an overkill for a website that gets used for a month out of the year, right? This is the JNation website, and it's relevant the month before the conference and maybe 2 days after the conference when people spike the traffic to see the recordings, right? Maybe I wouldn't put that much time into it. But if this is my mission critical website where people hang out every single day. So for example, if you think Facebook or Twitter or Gmail, right? They're the kind of websites that do this kind of performance optimization because it's worth the cost. If it's my personal website or the JNation website, for example, I usually stop at the network tab. I got them to get there as fast as possible. Most people won't be on these websites for more than half an hour. Irrelevant. But if it's the right kind of website, I'd look at making the JavaScript calls as efficient as possible. Instead of having 4 request animation frames, I'll try to have just 1. Instead of having 5 DOM events, I'll try to have just 1. So that's the other bit that's relevant to JavaScript is the garbage collection. And there's 2 types of garbage collection happening in browsers. One is the minor garbage collection, and the other one is the cycle collection graph reduction. The minor garbage collection is what you want to see on your website because you have, so the same way you have a DOM tree, JavaScript objects kind of live in this graph structure, looks similar to a tree, right? And the garbage collector is going to go and try to snip out parts of the tree that it can, right? When it can't and the graph gets big enough, there's a whole different thing that's going to go from the top to the bottom and try to shake things loose. The thing that goes top to bottom is called the graph reduction, and that looks at the entire thing, right? And that takes more time. The thing that's minor is just that the ends of it get snipped. And you want to see more of those minor things get snipped rather than trying to shake the entire tree. You can think about it like that. So graph reduction, bad. We don't want to see that. And that's because, why does graph reduction happen? Because you keep piling on objects and objects and objects in that JavaScript memory. But if you get to delete them, there's a magic keyword in JavaScript which if I look at most websites, very few of them actually use it, called delete. After you work with the JavaScript object, you can delete it. It deletes it from memory. It stops it being in that tree in memory. It basically deallocates it. And that's what you want to do with most of the things in JavaScript after you're done with them. There's another type of thing that happens, and that's event listeners, especially in front end, in the front end, in like everything that's got to do with the DOM. Very few people kind of, deregister an event after they're done with it. The event keeps, even events that only happen once, or event listeners that only happen once, right? Like load and everything like that. They stay registered because nobody kind of remembers to deregister them at the end. And that's what causes this graph reduction to happen. If you're careful and you do the other thing, you'll see cycle collection and minor garbage collection happening, which is the thing you want to do. So in here, for example, you've seen it managed to do 2 of the small ones after it did 1 of the big ones. And you want to see more of this. Set interval, that's interesting. One of the other things that you can deregister at the end of, after you're done, is set timeout and set interval. When one of the quirks of set interval and set timeout, actually they return. So you can do some variable name equals set timeout, but that's because set interval and set timeout give you an ID, and you can cancel them. The same way you set interval, you can cancel the intervals based on that ID, and not a lot of people do that as well. Let's try to look at something else, and I want to see what happens when I do a refresh of the page. So you can see my frames per second kind of went close to 60, close to 68, scrolled, they stalled. But in here is when I did my shift refresh, and that's everything kind of dropped to 0, and it started reloading things again. So in here, it loaded a bunch of JavaScript. Ooh, that's a big one. So you can see, because of the request animation frame, there's actually, it's a combined event that triggered off 7, 8, 9 other events, which is recalculating style, applying those style changes and layout shifts on top of parsing new HTML. So that means the request animation frame actually made changes to the DOM. It created the new element, and that needed a lot of time to calculate, which is, most animations work this way. If you manage to trim down your animations to always be there, you're doing a different thing, and that your DOM is going to balloon out and everything is going to be in place, and you're using presentation logic to display. And that's going to affect your network performance, but it's going to improve your JavaScript performance. Which one's better? That's up to you to figure out based on your website, right? What happens here, though, is because there's so many CSS files, as they come into that website, the browser tries to absorb it, recalculate the style of the entire page, and then apply those style changes. When it applies those style changes, if there's a layout shift, if something in the DOM changed, right, and there's a new layout happening, it's going to flicker for a split second white, right? And then the layout happens, the new layout happens. And you're going to see on some other websites where the flicker, you can actually observe the flicker. There's going to be a green event called paint. That's when the entire thing gets kind of chucked into the bin. It says, I can't figure out the layout shift on this. I can't do the math to change layouts. I need to start over, drop it, and create it from scratch, right? And that's when the noticeable shift happens, the noticeable white flash happens. I'm really happy that I haven't seen a single green dot in here. And that means all the CSS changes are kind of incremental. So the browser can figure out how to go from one to the other without having to drop the entire thing. It still changes things twice. And that means some of the CSS in there overrides one. So it's got competing rules. And that's usually when you use a lot of frameworks in between and you override the framework, right? There's a lot of tools in there that are going to shake out your CSS to make it as performant as possible. I would do that. I would kind of run the entire thing through a CSS precompiler at build time and kind of throw away any of the competing rules. So I wouldn't, things like important, for example, right? That's a big tell that your CSS isn't the best out there when you're using things like that. So I try to drop that as much as possible to stop having these layout shifts or recalculate the styles and have this as well. Ooh, DOM content loaded, that's when it loaded. I can even see that when it's happening. Function calls, oh, function calls happen because of lazy images, which is actually a good thing, right? The fact that you have so many of them, I can actually see what the function call was. Minor garbage collection, that's one of the things you want to see in your garbage collection, this minor garbage collection right here. Message port, that's an interesting one. I don't think I've seen message port in any website so far. Serialized data. I need to look into that. Actually, let me make a note. It's probably one of the ones I've never seen in here, and I have no idea what it is. And I think that was the end of this rainbow. Let's see if I shift things around in here, if there's anything else that's happening. No, it does look like the long polling, the request animation frame are the things that are the longest one. And if I look at the website, right, I don't really understand what's animating. Like, what's the thing that continues to animate when I do absolutely nothing to it? And that's a big tell, right? That's one of the biggest tells that something's happening that it shouldn't. I try to figure out why things are animating, especially when they're not on screen, right? What's the thing that keeps needing to animate? And I've changed that.
It's WordPress. That's that.
Yes, it's WordPress. So first action, ignore everything I've said in the first 37 minutes of my presentation, right? First thing I do to improve it is get off WordPress. I'm kidding. I actually started out as a WordPress developer. I know it's gotten better over time, but here's there's not a lot of things you can do past this. It's basically micro performance optimizations. You're at this point where, yes, you can still improve the performance, but it goes from 80% better to 82% better in 10 times the time. You have to really ask yourself, do you really need this? For example, I used to work on an app which was for an energy company. And we had probably one of the most performance web apps out there. It was written in Angular, so we had to be performant, right? But then we looked at how our clients were using it. Everybody was on the website once or twice a month to give us their meter readings, right? So everybody had the website up for like a minute, 2 minutes while they inputted the meter readings, and they never came back, right? That was it. It was the fastest website there, and we spent a lot of time to make it super fast, but nobody was using it for half an hour. The only people who were using it for that amount of time, it was us, the developers. So we were kind of putting out all that effort into it to solve our own problem. Even though it was a single page app, it was a web app, everything like that, our users, or 90% of our users, stayed on the website for a minute at a time, once a month. And that was it. They got an email from us, an email notification about the meter readings. They went on the website. The website performed admirably in those 2 minutes for them. It was fast. It didn't need to be that fast. We spent a lot of time kind of optimizing it. And that was on us. That was on the engineer. So you have to think about not only, can I make this website faster? You can always make a website faster. The biggest question is here, do you need to make it faster? When you need to make it faster, you have to understand that this performance bit helps you only maybe 10% of the way. And it's things like some of the things in here, and it shows that you're using a framework for it. There's things that have to do with vanilla JavaScript in here, or things that have to do with manually writing JavaScript that are going to show up the most, or things that have to do with frameworks that are out of your control. So the request animation frame, that's jQuery. That right there is jQuery. You can figure out if you want to move off of jQuery, right, and write your own animation to be super fast, super performant. But then you have to ask yourself, is it worth all that trouble? If this was Facebook, yes, hands down, in a heartbeat. If your website stays open for like half an hour, everybody stays on it, yes, definitely. If it's Discord, for example, or anything like that, yes, definitely. If it's the JNation website, I wouldn't. Like, don't get me wrong. Right now, even though I bashed on it for a good 40 minutes, I bashed on it, right? It's actually a performant website that does what it needs to in like 3 seconds and a bit. It's good enough for me, especially since I've been on the website maybe 10 times in the last month, right? It performs admirably for what it is. Now, assuming you're working on a single page web app that stays open, and you did everything you could out of the performance tab or the network tab, you'll see that's not enough, especially if you use a framework like React or Vue, or God forbid, I'm the biggest Angular fan out here, but it's one of the biggest memory hogs out there. So if you're using one of those frameworks,
I like you a bit more now.
I'm an Angular person. I usually bash on React, right? But I do understand all frameworks have their own. Every tool has their own use, right? And some of them, Angular is amazing for big websites. React is really good for websites that change a lot, and Vue is kind of in between, right? But they all have an effect in memory performance, and that's because some of them can't delete. When you have a cycle that keeps running, like the Angular cycle that keeps running and running and running, you can't exactly delete that. So that's gonna kind of add on to memory. And you can see how the memory changes. I think I've had this website open now for maybe 15 minutes. So I had 24 minutes first and then 15 minutes now. I think it's good enough. If I go to the memory tab and I take a snapshot, again, memory, as soon as you look at it, it starts affecting memory. So you have to take a snapshot of it in time. And for example, memory, because I took a snapshot, it changed. In the second after that, it changed. But I got a snapshot at that point in time. It shows me what that memory is actually used for. So if I've improved my network and that I've improved my performance, there's some things that are kind of architectural shifts that help me figure out what to do next. So for example, this is all the memory that the website is using compartmentalized into different bits. So for example, the purple one is everything that has to do with DOM. The light purple, the dark purple one is scripts. JavaScript objects are here, strings are there, and that's basically miscellaneous. A lot of the things in other have to do with everything but your website. So for example, using some sort of modern JavaScript and the browser has to adapt for it, or the browser has to shim for it, or even the fact that I'm running extensions in my browser. So for example, I'm using Grammarly as an extension, as an add-on on my browser. It shows up here because it's a script that runs in parallel to my website and affects my memory, right? What you want to look for is this DOM node here. So if I look on the JNation website, document is only 1. And that's what you want. If I go on Twitter, for example, the document count is maybe 2, maybe 10, depending on how much I've been on it. And that's because of that infinite scroll. Most websites that have an infinite scroll are going to have document counts that are bigger than 1. And that's one of the bad things, because you basically have an old version of your document and a new version and the new version and the new version in memory for how long your website stays on. So technically, your website is 10 websites running in parallel, right? Or in memory, it's like 10 websites. And that's going to drastically decrease your performance. After half an hour, your website can't cope. After half an hour, it's going to kind of give up. The fact that there's just one means I'm not doing any sort of lazy loading of the entire DOM content. I'm not basically serving you a different website in front of you. Now, here's the kicker. There are single page apps that basically do that. Whenever you do, I think it's called dependency injection. So whenever you're injecting a whole router in Angular, for example, that's basically a second sub app, a second document, and it shows in there. And the trick is to kind of clear whatever you had. Basically, throw everything away and force a refresh. You can force a refresh from JavaScript, and that's it. Instead of going from one route to the other, and it's basically 3 different documents, do a small little refresh before you load the next one. It's going to load anyway. You're going to have a half a second delay. But after you've been on the website for like, I don't know, maybe 30 minutes, that half a second delay is worth it instead of having the 7-second delay in between. I clicked the button and the website actually did something because there was no space for the JavaScript to run, right? So that half a second delay to just drop everything you have and start fresh, basically refreshing the page, is worth it. You see a lot of PHP websites that do that because server-side rendering, right? They need to re-render the page. It's actually one of the most performant ones because it can't do single-page application. If you try to mimic that behavior in your single-page applications, you lose half a second because of it, but you gain like in the long run. And you have to think about things like that. Now, everything that's in here compared to the document count is small, and that means the document is big, but none of the sub-elements in it are as big as the document. And that means I've probably seen in the performance that the biggest layer was 5 layers deep. So the HTML3 was only 5 layers deep, which is amazing. If I go on my own website, I think I've got like 12 layers deep, and that's because I'm lazy and it's presentation. But you can see things in here, and I could improve the performance of my website by doing that. I'm just lazy, and it's not worth it for me. For this website, for example, that's actually really good. It's one of the things that it's not that many layers, and it helps the memory performance. The script, all the scripts show up in here, and it's basically one of the things that I'd improve is you have inline scripts. The ones that say no file name is because there's inline scripts in there, and now that might be the inline scripts might be analytics, it might be my extension, it might be nothing, but I tried to get away from inline scripts because inline scripts kind of remain in memory, whereas the scripts that are external are actually more performant to run. I know, shocker. So I'd look at that. The fact that there's no file name, it's probably one of the only things I'd improve in here. The fact that you have a lot of scripts loading is going to show you a lot of small little things. If you had just the one script, like if you compressed everything for HTTP reasons, it's going to show as a single thing. The objects is the objects are.
Alex, sorry to interrupt. I just want to let you know that we have 3 minutes left only.
I figured that one. I'm looking at the timer, don't worry. So the fact that you've got objects in here, objects are kind of classified by what they are. The fact that the call stack is a bit big means you've got maybe 7, 8 layers of abstraction, and that's again jQuery. At this point, I wouldn't touch it. But if your call stack is bigger than the object stack, it means you have a problem. Usually the call stack, most websites, the call stack is really small because you don't have 12 functions calling each other in a chain, right? And that means probably you've got a lot of callbacks or a bunch of crap like that. If you want to refactor that call stack, it only becomes a problem when this call stack balloons more than anything else. The strings, there's nothing you can do about the strings. Strings are strings. You can't make strings somehow smaller because strings kind of get rid of the white space or anything like that, and you can't touch that bit. Right? I think that was everything I had. So if you want numbers instead of pretty boxes, you can change how you view this, and it gives you numbers and stuff like that. But it works kind of the same way. Memory performance and the JavaScript performance, you can save the snapshot and send it to somebody else so you can work together on the same thing. And I think that's my talk right here. If you want to, after this, if you've got questions or if you didn't feel comfortable asking, you can always go to my Twitter and DM me. I've got open DMs and I'm always happy to help. If you'd like me to do this exact thing on your website without the entire world, or I don't know, the 500 people on YouTube figuring out what's what, DM me and I'll take a look. I'll make a video and I'll send it to you so you can use it for your own website without having to, public shame you like we did here for JNation. JNation, I'm really sorry. This wasn't really a shaming, a public shaming. It's actually one of the most performance website I've used for this talk. Like if you want to see bad performance, I think you could look at the gift card thing I did, or at the Singapore e-commerce platform, which were really bad. This would be my top 10 in terms of performance. So I think you're good. You can call me back next year.
Yeah, we were concerned about it because it's not optimized. It's a WordPress website that we didn't spend a lot of time optimizing. So yeah, good news.
Cool.
Okay, so Alex, I want to thank you very much for your presentation and ask everyone that is seeing it to ask questions on YouTube channel or on Slack. We are running out of time. For now, we don't have any question. Let's wait couple of seconds.
Okay, so while everybody's kind of figuring out the question, I need to do this because otherwise my HR person is gonna kill me. Hopefully they're still watching. So if you're looking for a job, this wasn't about Fidel, but if you're looking for a job, if you're looking to work with cool people that build APIs, financial APIs, there's actually a lot of job openings in Portugal right now. I think somewhere at the bottom. There's a lot of job openings for Fidel right now. I'm sure Beatriz is our HR manager. Beatriz would be really, really happy if you take a look. So they're looking for a bunch of things like front-end engineer and back-end engineers. You can actually try to be a tech writer in my team as well. But if you like me or the things I do, you can try to join me.
Well, Portugal is very hot in the IT world right now.
I'm based in the UK. I wouldn't know, but by the amount of open roles we have in Portugal as opposed to London, for example, I think Portugal is where everybody wants to be. Yeah. Maybe because it's hot and sunny, and I see most of my coworkers working from the beach. I think I'd try to move to Portugal myself.
You'll be very welcome. So I think this is all because we don't have any question. If you have questions for Alex, you can ask them on Slack later on. If you can join Slack and join the discussion, you will be very welcome, Alex.
I'm going to be on Slack. I'm already on Slack. I'm going to be on Slack all day if you've got questions. And if you've got questions after today, just go to my Twitter. I've got open DMs. I'll always answer questions.
Okay. So thank you very much for your time. Hope to see you again next year.
Thank you so much.
Bye. Thank you.